Hey guys, welcome to my channel and I'm back again with another really interesting coding interview question video. In this video, we are going to solve again a LeetCode premium question guys, which is 1056 confusing number. So let's get started with the problem statement. Basically guys, problem statement says that a confusing number is a number which when rotated 180 degrees becomes a different number with each digit as valid. So let's see which digits are actually valid. So for example guys, when you rotate these digits, so 0, 1, 6, 8 and 9, when they are rotated 180 degrees, they are becoming our valid digits. So 0 and 1 and 8 remains the same. So 0, 1, 8 remains the same. When 6 is rotated, it becomes 9, and when 9 is rotated, it becomes 6. But they are all valid. But when we rotate 2, 3, 4, 5 and 7, they become invalid digits. Okay. So what we have to do is, after rotating a number, we first have to ignore the leading zeros. Okay. So if you are rotating a number and there is leading zeros, you just ignore it. For example, if you are rotating 8000 and you have got 0008, then it is just considered as 8. Okay. So we don't have to consider the leading zeros. And we have to return true if a number is a confusing number. That means if the number is a valid number after 180 degree rotation, we return true that it's a confusing number. Otherwise, we return false. Okay. So that's the problem statement. Let's see some examples. So for example, if you have got 6, right? If you rotate 6, it becomes a valid number, which is 9. So it is true, right? Because it's a valid number. If you rotate 89, it actually becomes 68. So you basically rotated 180 degrees, and that is also fine because this is a valid number. But if you have got 11, you can see that it becomes 11, but it's not a valid number because the definition of the confusing number says that it should be a valid number and it should be a different number than the original number. So if it's 11, when you rotate it becomes same 11, it is a valid number, but because the value is same, it is not a confusing number. So that's why we return false. And similarly, if in these examples there were number like 2, 3, 4, 5, then also we would have returned false because they will lead to an invalid number. Okay. Let's see some constraints. The constraint says that the number n, that means the number that we want to rotate, goes from 0 to 10 raised to power 9. So it is pretty huge number that we are going to deal with. Let's jump into the solution approach, how we are going to approach it. Okay. So the first thing first guys, we have to come up with the algorithm to find the individual digits. Okay. So first of all, if you want to find the digits of a number, you do basically two steps. You first of all mod the number. So for example, you mod with 10. So let's say if you have got the number as 89, if you mod this number with 10, you will get 9. And when you are going to mod 8 later on with 10, you will get 8, right? So the first step is to mod the number, and the second step is to divide the number by 10. Okay. So first thing is you mod it by 10, you get 9. Then you divide 89 by 10, you get 80. When you divide 89 by 10, you get 8. And then again you go back to the first step and then you mod again. Okay. So then you mod again until and unless you actually go to the point where your number becomes 0. And that's how you find the digits. But what happens when you find a digit? So let's say I have extracted the digit from the number. I have to find out if it is a valid digit to rotate. So if the digit, it is between these values, then we simply return false. Why? Because if you rotate these digits, you don't get any output, right? They are invalid number. In else case, we are just going to rotate 6 and 9, right? So we just rotate the 6 and 9 and we finally get our true number. So now we get our whole number, and in the end, when we have rotated the digits and we have gotten our number, we just compare, and if the comparison is valid, we return 1, otherwise we return 0. Okay, so it's a pretty straightforward solution algorithm. Okay. So we have to find the digits. For that I have already written modulo and then division. We have to see if they are valid digits. If they are not valid digits, we return false. If they are valid, then there is only one use case where we have to rotate, that is 6 and 9. So we rotate it. We get our full number here and then we compare that full number to find out if it's valid or invalid. If it's same than the previous number, then it's invalid number, you return false. If it's not same, then you return true. Okay, so that's the whole algorithm. Let's jump into the coding part. So first of all, guys, we need to find out the digits from the original number, but we need to compare it with the new number, right? So what we do is we create two variables. One is num and one is new num. So the num variable is actually initialized to n, that is the original number, and the new num is initialized to 0 because we are going to build this number. Now we will start extracting the digits. For that, we are going to run a while loop until the number value is greater than 0, because we are going to keep dividing the number. Once the number becomes 0, it means we have iterated through all the digits. Okay. Now we simply do modulo, right? So we find out the digit by modulating, by finding out the remainder of the number with 10. So this is the digit which we have found. So first thing first is we check if the digit is valid. So if the digit exists between 2, 3, 4, 5, 7, it's invalid. So we don't even have to iterate the entire number now. We simply return false. If the digit is not present in this array, it means it is a valid digit, and then we just have to check if the digit is 9 or 6. If the digit is 9, you basically make it 6. And if that means if that's not the case and the digit is 6, then you basically make it 9. That's the only use case of a valid digit, right? Where you have to make some changes. Otherwise, all the digits are going to be same. So now you have got your digit, right? Now I want to rebuild my original number. So the way I broke my original number was by doing a modulo, right? Modulo with 10. And now I want to take this digit and I actually want to make it my new number. And for that, there is a simple algorithm. What I will do is I'll take my new number. So this is my new number. I'm going to multiply it by 10 and then I'm going to add my digit to it. Okay. So this is how you keep on adding the digit to the back of the number. So let's say initially your number was, let's say 89, right? So you got the modulo, you got the digit 9. So the 9 will come first, and or basically 6 will come first. So it's gonna first make the new number is 0. So you 0 multiplied by 10 and you plus 6. So the first digit will be 6. And then in the next iteration you will multiply 6 with 10 and then you will add 8 to it. So in the end it will become 68, which is what exactly we want, right? So this is how you rebuild the new number. And when you have rebuilt the new number, it is time to now divide your number with 10. So you can go to the next digit. Okay, I'm going to delete this thing. So you just divide your number with 10. So you can go to the next digit. Finally, guys, after this whole while loop is over, your new number will have the rotated number. Okay. So this is your basically rotated number. So what you want to see if the rotated number is not equals to the original number. If it is not equals, then you simply return true. But if it's equal, you return false. Okay. This is pretty straightforward. Let's run the command guide. Let's see how it works. And you can see it passes the test cases. And let's submit it as well. You can see that the solution is accepted. Now jump into the next part, which is the time complexity. So you can see, guys, what we are doing here is we are basically finding out all the digits in the number, and then we are going to find out if it's valid or not valid, and then we are rotating it, right? Because we are going through each and every digit, and as in the description we have seen that this is a pretty huge number going up to 10 raised to power 9. So it is possible that there could be n digits in this number, and because we are doing a iteration of each and every digit, the time complexity is order of n. Now if I talk about the space complexity here, now the space complexity here could also be order of n, guys, because what we are doing here is we are rebuilding a new number, right? So if I am saying that I have got n digits, I have got a new number as well which has got n digits. So in that case the space complexity is also order of n, because you are building a new number completely which has got n digits. Okay, so that was the video, guys. I hope you guys like this video, and if you like this video, guys, then please do not forget to like this video and share this video with your friends. If you have any questions, comments, suggestions, feedback for me, please do write down in the comment section below. I will be really happy to address them. And in the end, guys, if you have not yet subscribed to my channel, please do subscribe and hit the bell icon for future notifications of more such programming and coding related videos. I'll see you guys in the next video, guys. Until then, take care and bye bye.